Welcome back everyone, and today we're going to be making a DIY automatic melting point apparatus. Ignore the hair, I look absolutely deranged. But yeah, if you're not familiar with chemistry, you may be like, what is a DIY automatic melting point apparatus even used for? Well, the quick answer is it's used for characterization. So if you have a compound and you want to see if it's the compound that you think it is, you test its characteristics, and one of the characteristics you can test is its melting point. So if you have a compound, say urea, and the literature says, hey, this compound urea, which we know for sure is urea, melts at 132 degrees Celsius, and you have a sample which you think is urea and it doesn't melt at 132 degrees Celsius, well, it's not urea, right? Because it's a different melting point. So the point of the melting point apparatus is to measure melting points and see if it compares to the literature values, which allows you to help confirm that the compound you made is, well, the compound you think it is. This was about a 4-month project. Yeah, it took a while of tinkering and getting this whole thing to work. And she is sexy. She is sexy, ain't she? Look at that. Look how good I made that look. The blue just looks so good. Just looks so good. And the insides look even better. Okay, I shouldn't have said it like that. But yeah, the insides look even better. And yeah, so let's go back in the past to all the footage of me actually building this and the process I went through to build it.
So the first thing we are going to need to make for our melting point apparatus is an aluminum heating block. And well, we could just buy one, but that's lame. So we're gonna make one ourselves by casting it out of aluminum. And I'm gonna use this as our mold here. It's just a piece of foam board. And I'm gonna cut out a decent chunk of it. It's about the thickness that I want. Ignore the dogs having a seizure in the back, but I'll go ahead and cut this up. Okay, so now what I'm going to do is add a spur, and this is where we'll pour our molten metal into. And then I'm going to adhere it to right there using some hot glue. And there we go, our aluminum heating block mold is complete. So now it's time to make our investment. So first I'm going to add a cup of plaster of Paris, and then I'm going to add half sand. And now I'm going to go ahead and add water. And this will make up our investment. So I'm going to go ahead and take our mold, and I'm just going to add our investment. Well, not our mold, technically it's just our casing, but I'm going to add a bit of our investment, just like so. And we'll take our part we made here, and we're going to put it into our investment and shimmy it up and down so we get any air bubbles out and it gets a clean cast around it. And that should be good. Now we just gotta sit here and wait for it to cure. Okay, so here's our final mold. So all we gotta do now is throw this in the foundry over there and burn out all this styrofoam, and then we'll backfill it with aluminum. Okay, so we got oil in our reservoir, and I got the foundry kind of prepped. We'll go ahead and ignite this up. Yeah. Oh my god. Oh, that is toasty. That is toasty. So let's take our mold out. Oh, wow. That is one hot mold. Go ahead and throw our aluminum in. Oh. And we'll melt these down. Go ahead and pour it in. Okay, there we go. Okay, so it's been an hour now, and this thing is still kind of hot, so I'm going to just throw it in some water. Now it's time to do some trim work and some sanding. Here is our final block. It is nice. You see there is some pitting from the casting process. There's ways to remove that during the cast, but it's really not that big of a deal because this is just a heat block. First thing we're going to have to add to our aluminum heating block is a thermocouple. If it would focus. Come on, focus, focus, focus.
There we go. Anyway, so we're just gonna add this thermocouple. So I'm gonna use this drill press here and drill a hole for the thermocouple, and then I will thread that in there. So we'll have good contact and we can measure the temperature of our heating block.
Okay, so here's our finished machined block. Ignore this in the back. We are going to be using this, but it's just a fiber optic cable. It's a high temperature one. And on the end here, I got a photoresistor just taped on. So the idea behind our automatic melting point apparatus, right, is our sample, the little tube slides in there, and it goes into here. And that will block some light coming from in the entrance because I'll have a light up here illuminating this. And as it melts, more light will be transmitted. As it becomes more transparent, more light will then go through the fiber optic and then go down to this photoresistor there. Okay, so here's a preliminary test setup I got going. So here we have a thermocouple entering our heating block. We have our heating element, which is from a soldering iron. It's set to max temperature right now, I think. But I decided to use the soldering iron because, like, perfect. It's small size. You don't need to really, you know, have a lot of heating power. And it's just this nice, small little heating element, which just slides right in there. Perfect, right? Perfect. Yep. And then here's our photoresistor circuit. It's pretty simple. You just have these resistors here, and then that goes to ground, and then our photoresistor is going to the positive terminal, and then we're supplying that with 5 volts. Okay, so let's go ahead and give this bad boy a test run real quick. So up over here, I got Arduino up, and I just made some basic code. Yeah, it's probably awful. I'm not good at coding. Just YouTube tutorials, that's pretty much it. Yeah, so right here we have it reading off all of our data, if you can see down there. So it has the temperature and the luminosity. And then over here is the serial plotter, which is giving us, you know, just the data in plot form, which is pretty nice to see. So yeah, so you can see right now we're only getting a luminosity of 1, 2, pretty much nothing. So what I'm going to go ahead and do now is turn on this flashlight. I know, very scientific what we got going here. And that should then be shining light through. It's coming through this fiber optic cable around into our photoresistor, and then our circuit is measuring it. And as you can see, yeah, our luminosity jumped up quite a bit. The max value is 1023. I don't know why it's fluctuating a bit. I mean, it's probably because it's just a flashlight. But I'm gonna give this a little bit of time to stabilize. So what I'm now gonna do is take these, they're just melting point tubes, as you call them, out, and then we'll kind of see how putting this in there affects our luminosity. So right now we're reading 460, so let's plop it in. Obviously there's no sample in that right now. Whoops, there it is right there. And as you can see, the luminosity jumped down to about 286. So the glass alone changes the luminosity quite a bit. I'm gonna take the glass out, and you see the next value jumps up. But yeah, let's go ahead and load this up with a sample. Okay, so I found something that we are going to melt. It is just Splenda. So yeah, I mean, it is a mixture, but it should melt clear, and we should be able to see our change in luminosity. Here's our nice sample of Splenda. And so right now, what are we reading? 450 luminosity. Let's go ahead and add this in. And you see we dropped down to 175 luminosity. So using our serial plotter over here, you actually see the drop in luminosity. But we'll go ahead and turn on the heater. Okay, I got the heating element going. And yeah, well, you can already see we're getting an increase in temperature, and our luminosity is staying pretty stable, so that's very good. Okay, by our graph here, we're starting to get a change in luminosity. Temperature's around, what is that, 80 degrees Celsius. So yeah, our sample is definitely starting to melt. So let's see if we can have a look in there. Yeah, if you can see in there, it is starting to melt. It's clearly starting to melt. And that's why we're getting that change in luminosity. Okay, so a couple days later, here's where we're at. Yeah, it's a bit more complex. But anyway, we just have some relays here, which control power to our heating element. We have an LCD display here. And then we have these buttons which help control it. But anyway, the basic idea that we have going now is this is pretty much just a reset button here. So it just resets the Arduino. This button right here does the manual melting point test. So this will put it into manual mode where obviously it's not automatic. And then this one right here is for our automatic mode. As you can see on there right now, it says ready and then the temperature going. So what I'm going to go ahead and do is start this bad boy up and kind of show you how it works. So I'm going to take our flashlight here and put it in, and then I'm going to go ahead and start automatic mode. Okay, well, there it goes. So right now it's just taking the luminosity and just measuring it pretty much. So at first it does 20 measurements of luminosity to kind of let it stabilize, and then it will do 20 more and then average that, and then that will be our base value luminosity. So you can see it says average luminosity is 177, and then it's going to go ahead and start the melting point process. So you see the relay powers on. This would theoretically put power, into our heating block and start heating it up. And then, see, once I take this out, boom, melting point calculated at 22.75 C. That's just because the luminosity increased once I took that out, and it detects that, and bam. And then the relay turns off after 30 seconds. So yeah, that's the basic idea of it. And then the manual button just pretty much turns on the heater. It still displays the luminosity, but it's not really necessary, and just measures the temperature, and then you can see if it melts. So here's the code I got going here. It looks fairly complicated, but it's really not that bad. So pretty much when it starts up, this will constantly loop up here. So this just tells you the pretty much says that it's ready, and then it reads off the temperature because you want to see if it's cooled down enough to start your next melting point. So that's kind of the point of this. And then we have two main if statements. So this is pretty much if the button is pressed for auto temp, then this section of code runs. And then if the button is pressed for manual temp, then this section of code runs. And you see down here for the manual temp, it's pretty much just printing the luminosity values and the temperature values. And then this will repeat for a total of pretty much an hour, and then it'll automatically shut off because, pretty much over an hour it's been left on, and yeah. And then up here for our automatic, pretty much, again, this whole thing loops for an hour. But so one time, pretty much, this is pretty much saying, so only one time this set of code will run 20 times. This is the initial 20 measurements it takes just to kind of let it equalize. And then here's the next one where it averages another 20 that it takes, and then it averages that. And then it'll print out the average right here. And then below that, pretty much this is just running this section of code for an hour. And this just increases the temperature and is measuring the luminosity at the same time, and then also measuring the temperature. And this is going to keep repeating unless if the average plus 9 is less than the luminosity right here, then it's pretty much going to do this set of code. And then this set of code just lists the melting point equals, and then pretty much it just delays 9999999, and that's pretty much just saying it's just going to stay on melting point, what it equals pretty much forever until you reset the device. So there's still some things we have to add to this. So I bought this alone, which melts at 92.5 Celsius. I've given it some runs here. You can see that it did melt. So the biggest issue I'm facing with the automatic melting point is that it pretty much just turns the heater on full blast, and it doesn't give it good time to equalize. So over here may be hotter than over here, right? So then our sample melts at a lower temperature. I mean, it still melts at 92.5, but since our thermocouple is reading the temperature difference across here, right, it can be like 2 degrees off, even higher the higher the temperature you get. So that is an issue. So you could just say, okay, let's just take this little dial here and change the amount of heat this is producing. And sure, but if you want it to be fully automatic, you don't want it to sit there and keep dialing it till you get a good heating rate. Because at first, normally you dial the heating rate up, and then once it comes close to the melting point, you dial it down so it changes like 1 or 2 degrees Celsius per minute. And that gives time for this to equalize the temperature and give a more accurate reading. But yeah, for it to be fully automatic, we don't want to sit there and have to dial that. We're going to have to use this keypad here, and this keypad will essentially go on the front, and then you type in the temperature that your compound's supposed to melt at. Also, if I use this number pad here, I can probably just completely get rid of all these manual buttons. Okay, so here's what we got going here now. Came out perfect, and that will be our eye look through. Okay, so now that we got this, we need to secure our heating block, which I'm also going to make some modifications to the inside of our casing here. I'm just going to use this bolt, drill a hole, then screw it in the top, and then it will be mounted to the top of it, just like that. And the modifications I'm going to make to this is, one, I'm going to put the heating element on this side. So I'm going to drill another hole below, so the heating element is close to the thermocouple. That will be much better instead of opposite sides, so it'll give us more accurate temperature. So after all that drilling and putting screws in, and I kind of messed up a little bit right there, but yeah, you know, it happens. This is what we got, and it's looking great. Kind of the main next thing is to use this prototype board. So this just pops on the top of the Arduino, and you see it just has all these copper, like a perf board kind of. And yeah, you can just solder up the circuits on this, and then, you know, we can just have our circuit board. So we don't need like the breadboards and stuff, which kind of go all over the place. So yeah, we got to solder this whole thing up to get all of our circuits that we want. I'm going to print this Arduino just holder kind of, so this will keep it isolated from the metal frame of the casing and kind of just give it something to mount on. Okay, here is our Arduino holder after printing. Let me just scrape that off of there, and yeah, it should work. Okay, and here's the stand for the Arduino, and then we have our prototype board on top. Yeah, don't even ask. It's a very bad job on the top there, but as far as I can tell, none of the connections are shorted, and it should work. Okay, so this all looks like a disaster, but here's what I got going now. I mean, it is a disaster. Here's our front plate. So we have that right there, LCD, our reset button, our heating element control, our eyepiece, and our keypad. That's what the back of that looks like. And I 3D printed these little casings here so it doesn't short out on the casing, as you can see there, and just super glued it all down. And then we come over to here. I did put a new thermocouple in. The old one was just, it was done for. So there's that. I have it wrapped up with electrical tape on the top. I'll probably 3D print little brackets and do that instead, because that's definitely not going to hold. And then there's our chip there, the Max 6675, and then our cables here. And yeah, so now all we have to do is really just assemble this thing and wire it all together. Here's our prototype board, the awful soldering job. And I added this little buzzer on there too, so it'll know when the it'll tell you when the automatic melting point has been determined by, you know, making a little buzzing sound too. Yeah, and then here's the back, got the on-off switch and our power coming in. So only thing we gotta do now is pretty much just wire everything up. We're going to obviously make some changes with the code for using this. I decided I'm going to use a PID control and set that up so it doesn't overshoot the temperature. So yeah, I'm not going to bore you guys with all the soldering and putting this together, but yeah, I'm going to put in some work and assemble this whole thing together. We'll edit the code a bit and yeah, get it going. It's a couple days later and here's what we got. It's pretty much all completely done. There is the front of it. Got our number pad, reset button, manual heating controls, LCD, and eyepiece. On the top there, that's where you insert the sample. Those just hold the heating block up. And there's the back with an on and off switch. So let's go ahead and turn this thing on and I'll show you guys how it works. So now I'm gonna go ahead and flip the on switch. Boom, just like that, she is on. And if you can see in there, there's where the sample goes, kind of washed out. But yeah, so there's where the sample goes. You can see it's saying ready. Temperature's at 24 degrees Celsius right now for the heating block. And yeah, so if we want to, we can reset it there, and that's how you reset it. But so yeah, we have two options. So we have automatic and manual. So first we'll start with manual. So we just hold that and see the relay activates. Displays the luminosity, again, not really necessary, but there's the temp. And then we can turn that up to control the heating rate. As you'll see, the temperature should start to rise. There we go. Yep, so it's starting to rise. And that's pretty much that. And then you can just look in there to see when it melts. So let me go ahead and reset it, and then we'll switch to automatic mode to show you how that works. So we're gonna go ahead and press A for automatic. Okay, so now it's asking us to set the temperature. So pretty much the point of this is we set the temperature that's supposed to melt at. So, the literature value, say, is 100 Celsius. So set temp 100, and then we'll press any other button other than the numerical button, and there we go. And it's setting the temp to 100. The point of this is just so it slows down the heating rate, right? Because right now it's under PID control, so the heating rate goes fast and then it slows down. So you want to set it to the point so you get a slow heating rate for the most accurate temperature. So then it does like before, it does 20 runs just to let the luminosity stabilize. And I removed the average luminosity thing, and I'll show you later in the code of how that works. Yep, and there we go. And then now it's just going to PID control all the way up to 100 C, and it'll calculate our melting point automatically. Okay, so now we can open up the inside. Ooh. Yeah, I don't know why the LCD does that when it's, I don't know. So here is the inside. Yeah, it's pretty packed, and there's the light, super bright. So, well, yeah, there's our heating block, and I did wrap it in some KO wool, which is a ceramic insulation. Number one, it helps the temperature get higher on the heating block and prevents all this stuff from getting hot because it can't get hot. I also did have to add another power supply here, which powers the light, because I did have it on that power supply, but it drew way too much current. Speaking of that power supply in there, this is 3 destroyed microcontrollers, like $25 worth of microcontrollers destroyed, because somehow that got on like 12 volts, and I was powering the microcontrollers to the 5-volt pin, which goes directly to the AT Mega 32, I think, whatever. It goes directly to the chip, and an over voltage just completely destroys that. This one, I don't know how this one got destroyed. I think I accidentally shorted something and it blew. And then one of these blew due to the over voltage, and I said, oh, maybe it's just this board. Tried it on the other board, and it blew that one too. So yeah, anyway, but we got our other microcontroller down there, which is working fine. And yeah, that's about it. There's just our relays, that switch, power supplies, our heating block there. Thermocouple wire is right up there. And yeah, that's kind of about it. Also, we have a buzzer on the board, and I'll show you the buzzer later because it plays a cool song. And then right down there, we have our LCD, some more wiring, and our light. So yeah, that's the inside of it. It's definitely a little packed. I may eventually add like a small fan here to kind of blow air through to keep everything cool. But yeah, let's go ahead and give her a test run and see how she does. So I got 3 samples here. So the naphthalene's on the very left, the middle is the alum, and the last is the serotonin creatinine sulfate. So let's go ahead and test all these samples. So first, we're going to start with the lowest one, and that is naphthalene, which is right here. So we're going to go ahead and load that. Hello? Okay, now I have it in there the right way. Okay, let's do our melting point test now. So we're going to do automatic, and the naphthalene should melt at 81 C. Well, it's like 80.26, so we'll round up to 81 C. And yeah, we'll let that cycle through and see what we get out. Finish, give us a melting point of 85 C, so it's about 4 C over. And wait and listen for the song. And that just tells you that's done. And I did Christmas because it's Christmas time. As you can see by my window, I got here. And the main issue for that is the heating rate was a little too fast. So I can slow that down though, just changing the PID constants. Let's do our alum now. And our aluminum should melt at around 92 degrees. It'll give us a melting point of pretty much 95 degrees. And the melting point is around 92.5. So this is off by about, 2-3 degrees Celsius. So yeah, it's slightly off, but no big deal. I can, again, correct that. Okay, now for the final one, I'm going to set this automatic to 220. I think the actual melting point is like 216, so 220 will be a good set point. And then we'll let it rip. Okay, there we go, and our melting point is 219 degrees Celsius. I can also tell you there is definitely some serotonin in here because it smells like feces, and well, that's due to the indoles, so not a good smell. Okay, so here's a code for it. This is just library stuff down here. This is for the song that plays. I'll get into that later. More just setup kind of stuff. Kind of ignore that. Stuff that just runs once in the beginning. So then we have down here, then we have an if A, and that's for the automatic. And all the way down here, we also have an if B, and that's for the manual mode. So with this right here for the automatic, pretty much just runs this. And then this right here is just for the keypad. We pretty much enter the value of the set temp. That's pretty much what that's for. And then once that's pressed in, it's entered. And then, yep, this runs, blah, 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 keep going down. This is the PID control. So it does an aggressive approach originally, and then when it's 10 degrees away from the set temp, it does more of a conservative approach. And then, yeah, just more of the PID controller. And then pretty much then, turns on the relays and stuff. And then after a certain amount of time, well, if the luminosity changes a certain amount, then it determines the melting point. But yeah, that's kind of just the basics of it.
So that wraps it up for today's video. And yeah, there's our DIY automatic melting point apparatus. Sorry, I just have to keep saying that. It's addictive. And yeah, so you'll be seeing this in a lot of upcoming videos because it's going to be so useful. And over time, I'll probably end up giving it some software upgrades and stuff, maybe some hardware upgrades. But yeah, so I hope you guys enjoyed, and I will see you guys next time. Bye. No, wait, I wove my hand before I said bye, but bye.